This is the second video on Surds, and in this video we will be simplifying Surds. So in the first box here, we just refer to the number underneath the square root as positive. So let's just label each part. This is called the root. This is called the radical, and this is called the radicand. So for instance, the square root of 36, 6 is the root, the square root is the radical, and the radicand is 36. There's also another one, and this is called the index. We don't usually put the index of a square root if it's 2, so the root is just assumed to be x. So for example, 3 would be 2, because 2 times 2 times 2 is 8, and the root of 27 to the 3 would be 3, because 3 times 3 times 3 is equal to 27. Likewise, the fourth root of 16 is 2, because 2 times 2 times 2 times 2, or 2 to the power of 4, is 16. Okay, so we define our radicand as positive, that is greater than 0. So in this course, we don't consider negative radicands. If you want to have a further look at negative radicands, there are videos on that. They're called imaginary and complex numbers. Okay, so let's get back to our simplifying square roots. I just want to take a quick look at this. So if we have something, for example, the square root of 4 squared, we can show that that is 4. We multiply the radicands to get 16, which is equal to 4. So we can say that the square root of x squared is just equal to x, and we can show that just by doing this. In the general case, if we get the square root of x multiplied by the square root of y, that is the same as xy. For example, if we have the root of 2 multiplied the root of 3, that is the root of 6. If we have the root of 4 multiplied by the root of 5, that is the root of 20. But we can simplify the root of 20, which is what we're going to look at shortly. One big misconception, and I'm going to do this in red because it's really, really wrong, that the root of 4 plus the root of 5 is equal to the root of 9. Okay, you cannot do that. A similar example, the root of 10 subtract the root of 4 is the root of 6. You cannot do that. So in both our examples here, the root of 4 plus the root of 5 and the root of 10 minus the root of 4, the most that can be simplified is this. Cannot be simplified any further. That's very important. I see a lot of students trying to do that, and that is a major misconception. Okay, So let's look at some examples. Okay, so I'm going to simplify. Let's do an orange. Okay, let's do the root of 8, the root of 20, the root of 50, the root of 150. Okay, so when we have these are called composite numbers, we need to rewrite these composite numbers in this form, where x squared is a square number. So let's have a look at the square numbers. We've got n squared, 1, 2, 3, 4, 5, goes on forever. First square numbers 1, 4, 9, 16, 25. So we need to rewrite these using our square numbers. So this is a nice easy one. It's the root of 4 multiplied by 2. This is the root of 4 multiplied by 5. And see if you can do 3 and 4. Pause the video. Okay, so 3 is 25 times 2, and number 4 is 25 multiplied by 6. So let's do our second line here. I'm going to leave this at the top. This is what we need to get. This is the format we need to get. So we can rewrite this now as the root of 4 by the root of 2 using this principle. We know the square root of 4 is 2. Let's put some equal signs here. Okay, so pause the video and see if you can do 2, 3, and 4. So hopefully you've done that now. So we can rewrite the square root of 4 as 2 root 5. We can rewrite this, the root of 25 times the root of 2, as 5 root 2. The root of 25 multiplied by the root of 6 is 5 root 6. Now we can check all these. Let's check the first one. Okay, so we can take this inside the square root and do the opposite, which is 2 squared. 2 squared is 4, 2 times 4 is 8. So we get the original. So I want you to check 2, 3, and 4. So pause the video. Okay, so hopefully you've done that now. 2 squared times 5, which is the root of 20. 5 squared times 2, which is the root of 50. And we've got 5 squared times 6, which is the root of 150. That's the really nice thing about Surds, is that you can check your answers as you go along. Okay, so I'm going to give some more examples, and I would like you to have a go. So let's have a look at 2, 4, 5, 6, 7, and 8. So let's do the root of 8 divided by 2. Let's do the root of 20 squared. Let's do 2 root 8 cubed. Let's do 3 root 26 7 all over 9. And let's do an algebraic one. Let's do a, the root of a squared all over 2a. Okay, so pause the video and have a go at these. If you get the wrong answer, that's where learning occurs. If you get the wrong answer and you know how to put your mistake right, that is where learning occurs. And when you change your brain, that's what learning is, changing your brain, something called neuroplasticity occurs. And your brain is a plastic function. It can change. It's malleable. And when you're presented with an error or a problem or something you don't understand, that's where learning occurs. And your ability to overcome that barrier, something called perseverance, is imperative in your learning of maths. It's been shown through research that those students that can persevere with maths are the most successful. Okay, so you should have paused the video now and had to go at 4 to 8. We can rewrite 8 as this. I'm just going to jump a step. I think you should all be comfortable now that the intermediate step there is the root of 4 times 2 all over 2. So that is 2 root 2 over 2. We can cancel just to get root 2. Okay, so we've got the root of 20 squared. I'm going to keep it as the root of 20. And we can rewrite that as 4 root 5. So that is 2 root 5. So that is 2 root 5 times 2 root 5. 2 2s are 4. The square root of 5 times the square root of 5 is just 5. And that gives 20. Now, some of you might have done this. They might have done, well, 20 squared is 400. We can write 400 as 100 times the root of 4, which is 10 times 2, which is 20. Both are correct. Both are correct. Okay, so let's have a look at 6. So we've got 2 root 8 multiplied by 2 root 8 multiplied by 2 root 8. Or we could say 2 cubed multiplied by the root of 8 cubed. Both are correct. So we've got 2 times 2 times 2, which is 8. And then we've got root 8 multiplied by root 8 multiplied by root 8. Well, this just gives 8. So we've got 8 times 8, and we've already simplified 8 as 2 root 2. So 8 8 is 64. 2 times 64 is 128 root 2. We can do the same here. We can do 2 cubed, which is 8, and we can do 8 cubed, which is 512. Oops, 5, 1, 2, and we can simplify 512. We need to get a square number. So we can write 512 as 64 root 8. Well, that just gives, and we can rewrite this as 2 root 2 to give 128 root 2, which is the same as our example here. Okay, so I'm going to get rid of this and just leave the solution there. The secret to doing maths and being successful at it is to practice. It used to be considered old-fashioned to do every question. Actually, doing every question builds up fluency because you recognize patterns subconsciously in your head. So if you're struggling to do a topic, I would strongly encourage getting a maths book, starting at question 1 and doing every single question. That's exactly what I did, and I was successful in maths. Okay, so we can simplify 3 over 9 as this. We can simplify 27 as the root of 9, 3 over 3, 3 root 3, just cancels to give 3. Okay, so if we really wanted to check that on our calculator, we could do the root of 3 subtract, let's do a fraction, 3 root 27 all over 9. And if we've done the correct answer, we should get 0, which is what we do. Okay, so we can cancel this. This just gives a over 2. Now, you don't need to know this, but we're doing this very shortly. We can rewrite a as a to the half. Now, if we get a to the half and we square it, remember we multiply indices. That is just a to the 1. So that's another way at showing that the square of the square root is just itself. Okay, so I'm going to let you have some fun on each of these questions. And if you get very large numbers, let's have a look at 288. Now, I don't know how to break down 288 in my head, but if I do some calculations, I can work it out. That is a square number. So 2 times 144 underneath the square root, that simplifies to 12 root 2. Okay, so have a go at doing these questions here and pause the video. Okay, so hopefully you've done that now. So this is just the root of 7 times the root of 7. If we really want to show workings, this is 3 root 3 times 3 root 5 root 5. 3 3s are 9. This is the root of 25. 9 times 5 is 45. This is negative 2 root 3 times negative 2 root 3. This gives 4 root 9, which is 4 times 3, which is 12. This is 25 times 2, which is simply 5 root 2. 4, 3, 2, let's break it down, gives 2, 16, be broken down again, give 1, 0, 8, can be broken down again to give 54, can be broken down again to give 27, can be broken down again to give 9, which is 3 divided by 3, which is 1. So we can write 4, 3, 2 as 2, 4, 8, 16, which is a square number, times 9, which is a square number, multiplied by 3. Well, 16 times 9 gives 144. So we've got the root of 144 times the root of 3, which is 12 root 3. Okay, so we can simplify that as, let me write these as separate questions. We can write this as 2 root 2, which is 8 root 2, half of, that's right, 50, 72, 2 gives 36. This is a square number, so we've got 288 is equal to 2 times 4 times 36. 4 times 36 must also be a square number, which is 144. We've got 144, so 2 times 144. Okay, so we've got the root of 2 times the root of 144 all over 3. So this is 12 root 2 over 3, which just gives 4 root 2. Okay, so in my opinion, the measure of a good teacher is one that is able to show his students that he makes mistakes. Everybody makes mistakes, and if you pretend you don't make mistakes, you're going to end up making a fool out of yourself, because everybody's human. Mistakes are a distinctly human occurrence, and even my professors at university, some of the cleverest people I know, made mistakes on the board. Okay, so pause the video and have a go at doing these questions, and I will put the answers up shortly. Okay, so hopefully you've done that now. So let's have a look at the answers. The answers are here. So mark your work, and I will do 2 difficult ones. Let's have a look. Let's have a look at, I don't know which one looks difficult. J looks a little bit difficult. The root of 3,125 over 10. And which other one looks a bit nasty? Let's do M. 10 root. Okay, so how on earth are we gonna? Okay, now an obvious one to divide there. 3,125 is 5. So if we divide by 5 there, we get 625. We can actually jump and divide that by 25, which is a square number. That gives 25, which is another square number. Just gives 1. So 25 multiplied by 25 is 625. So we can rewrite this as the root of 5 multiplied by 625 all over 10. Okay, so this is just 25 over root 5 over 10. We can divide numerator and denominator by 5 to get 5 over 2 root 5. Okay, 160. We can divide by 16. Or if you're not comfortable doing that, we can divide by 2. To give 80, divide by 2 again. To give 40, divide by 2 again. To give 20, divide by 2 again. To give 10. And as you can see, this is 16. Root of 16 times the root of 10. That is 10 multiplied by 4 times the root of 10, which is 40 root 10. Okay, so hopefully, well, let's check to see if we got those two right. So 5 root 5 over 2, well, this is right. And m is 40 root 10. Whew. Okay, so keep up the good work with the surds. They are difficult. They're not an easy part of maths. Everybody struggles with them, including myself. And look out for the next video.